Good morning, guys. Welcome to today's lesson, April 15th, exterior angles. Our aim today, what is the relationship between the degree measures of an exterior angle of a circle and the arcs that it intercepts? First, the do now. In the diagram below, the measure of arc ABC equals 268 degrees. I've seen many students make the mistake initially when labeling, just that first piece of info there, this arc right there to be 268. That is not the case, and if you think logically about that, 268 degrees is almost the entire circle, right? We have 360 degrees in total. 268, that arc should be way bigger than that. But if you're determining which arc ABC is, start with A and follow it all the way around to B and then all the way through to C. So that's arc ABC, and that's what's 268 degrees. All right, and then they say, what is the number of degrees in the measure of angle ABC? So angle ABC is right here. What type of angle is that? Should be thinking that's an inscribed angle. So that inscribed angle, as that opens up, that's equal to half of the intercepted arc. So x there, it opens up, that angle opens up as follows. The intercepted arc is this arc AC right there. So the inscribed angle is equal to half of the intercepted arc. We don't have the intercepted arc. The arc we have is arc ABC, which is very, very significant here. So what we're going to do in total, right, the complete circle is 360. So if we take 360 and subtract the 268 off, we end up with a 92 degree arc there. All right, the inscribed angle is equal to half of that. So you take that 92, divide it by 2, and you get choice 4. All right, a little bit of a tricky question, labeling. All right, we haven't seen an arc represented with 3 letters like that. When it is, just follow it around. And then just know in total, right, of course, the whole circle is 360, so that's how we got that 92. We took 268 off of the 360. All right, nice little, before we get into the lesson, another do now question, 2-point Regents question, number 28 on a Regents. All right, a little review here. Find the value of r that will make the equation sine of 73 degrees equal to cosine of r true when, now this notation here is when essentially saying that when r is between 0 degrees and 90 degrees. So when it's acute, explain your answer. So you might remember questions like this, but the big idea to find r, we have to take 90 degrees and subtract off that 73 degrees to get 17. That would get you 1 point. Now why is that true? Remember the rule. Sine of one angle, let's say A, is equal to cosine of another angle, B, when A and B are angles that add to 90 degrees. All right, those are cofunctions. Sine of A equals cosine of B when A and B are angles that add to 90 degrees. So that's one of many combinations, but sine, you could say sine of 73 here is equal to cosine of 17. Any combination of 2 angles here, this and this, that add to 90 degrees. Another way that could look, it's not helpful, it's not part of your answer here, but sine of, let's say, 60 degrees is equal to cosine of 30. All right, sine of 15 is equal to cosine of 75. So any combination, sine and cosine are equal when it's any combination of 2 angles that add to 90 degrees, that are complementary angles. All right, so exterior angles, guys. Exterior, what does that mean? Outside, right? So some angles that are in the diagram here that are outside the circle, this 30 degree angle there, this 40 degree angle here, this 55 degree angle there, they're angles that are outside of the circle. Now, how are they formed? What's the rule? That's what we're going to get into here. So in letter A here, top left circle, this exterior angle is made from a line here All right, now circle terminology, that's called a secant. All right, it hits the circle twice and it extends into the exterior. Then that's there, we see we have an exterior angle. And another secant, so that's called a secant. We're not going to get too caught up in that, but just know that those are secants. In letter B here, we have this segment right here. That's another secant. It hits the circle twice. And JK, that segment there, is a tangent, because that only hits the circle at one point, point K there. So we have a secant tangent. That forms an exterior angle. And then letter C here, we have a tangent and a tangent. So two tangents can form an exterior angle. We're not going to get caught too much in the terminology, but as you can see here, we have secant tangent, tangent. Those are all different combinations that make an exterior angle. The good news for our purposes is the same rule applies for every single scenario in finding the exterior angle. All right. If you look at all these combinations of degree measurements, you might actually be able to tell the rule. But just like with the intersecting chords when we were finding angles, there's two intercepted arcs here. So let's just focus back in on letter A here. See how this angle opens up and this angle opens up. When that happens, essentially it opens up and it hits two arcs. It hits this arc here, that 35-degree arc, and it hits this arc here. There's two intercepted arcs. All right, the way you find the exterior angle, I know everything is filled in here, but actually let me back up a second. The smaller arc right here, the 35-degree arc, that's called the minor arc. And then the 95-degree arc, that's called the major arc. The way you find, using those two arcs, the way you find the exterior angle is you find the difference of the arcs, which would be 95 minus 35. So the difference of the two arcs, and you divide that by 2. 95 minus 35 is equal to 60. You divide that by 2, and you get 30. That's where that 30 is coming from. All right, just like in every single one of these examples, let's look at letter B here. That's the minor arc that gets intercepted. And then this 130 is the major arc that gets intercepted. To find that 40 on the outside, I know it's already filled in for you, but just to show you where it's coming from, you take the bigger arc, subtract the smaller arc, major and minor, subtract those, divide by 2. That's where that 40 comes from. It'd be 80 divided by 2, which is 40. And then the same thing here for letter C. There's a minor arc that gets intercepted. Remember what intercepted means. It just means the angle opens up and hits that arc. So the minor arc is 125. The major arc is really the rest of the circle. In this instance, the 235. So where that exterior angle comes from, the major arc minus the minor arc, and you divide it by 2. So it's the difference of the arcs, and then you divide it by 2. So it's sort of like an average with the intersecting chords that we talked about, but not quite an average because the operation is subtraction. All right, last time with intersecting chords for the angles, we added and divided by 2. Now we're subtracting and dividing by 2. All right, so your key idea to find an exterior angle of a circle, the exterior angle is equal to the major arc minus the minor arc. So that's just really, you can kind of substitute those words with bigger arc and smaller arc. The major arc minus the minor arc, and you divide that by 2. Okay, let's see how these examples look. So example 1, if the measure of arc AE, so right here, is equal to 88 degrees, so let's fill that in, and the measure of arc BD, right here, is equal to 40 degrees, find the measure of angle ACE. So follow that ACE, that's the angle right there. So see how this angle in the exterior, it opens up, right? Opens up. It hits the 40-degree arc, and it hits the 88-degree arc. So that's the 40 as we move through. I'm going to erase this, but this opens up, hits the 40, that's the minor arc, and opens up, hits the 88, that's the major arc. All right, so you just follow the opening, follow as that angle opens up, and you can see which two arcs we're dealing with. And a lot of times it's really the two arcs that they give you. Okay, so to find x, it's the major arc minus the minor arc, and then you divide that by 2. So we get x is equal to 88 minus 40 is 48, and divide that by 2, and you get 24 degrees. Alright, not so bad. So this is an exterior angle. Remember, it's outside of the circle. It's formed, it intercepts two arcs, a smaller arc and a larger arc. You subtract those two and divide it by 2. And you find that gives you the exterior angle. Alright, and this one, just think about what it was made from, this exterior angle. These two blue lines, these two blue segments, what are those called? Those are called secants. This one, in example 2, is made from two tangents. Remember, it's the same rule for all, but as we go through Module 5, you need to know what's a secant and what's a tangent. Okay. So if the measure of arc GKJ is 230 degrees, so follow that, G, then to K, then all the way around to J, is 230 degrees. Find the measure of angle GHJ, which is the exterior angle, but that's what they're asking for. So remember, it opens up, it hits the minor arc right there. Oh, we don't have that. And it also opens up, hits the major arc. We do have the major arc of 230. Right now we don't have the exterior angle, and we don't have the minor arc as well. So how would we find that minor arc, this minor arc right here? Well, hopefully you're noticing that that minor arc, it completes the circle, right? This green line and then the blue line, that's the whole circle. That's the circle 360 degrees in its entirety. So once again, you take that 360, that's part of the reason we had that do now today. Take 360, subtract the 230, and you get 130 degrees for the minor arc. So the exterior angle is equal to the major arc minus the minor arc, and you divide that by 2. So x is 100 divided by 2, which comes to 50 degrees. Alright, let's keep it moving. And now guys, really I'm just giving you a rule for the day, and you go with it. If you want, try them on your own. If you want to keep watching the video, alright, totally up to you. Example 3. In the diagram below of circle C, the measure of arc QT is 140. As I read, I'd like to fill in right away. I suggest you do the same. Alright, so our arc is 140. And the measure of angle P, that's in the exterior, is 40 degrees. What is the measure of arc RS? Now, what is different about this problem? You're looking for the minor arc. Before, all we've worked with is find the exterior angle. Find the exterior angle. Here in example 3, you're finding the minor arc. You're given the major, you're given the exterior. We have to find that minor arc, that smaller arc. So just set it up just like you would normally. The exterior angle, which we used to be writing x equals da-da-da-da, right? Now we're writing the exterior angle, which we know is 40, is equal to the major arc, 140, minus the minor arc, which is now x, divided by 2. I just kind of want to make a note here. This is the exterior angle. What we used to be in other problems we were solving for, in this one we're given. Now the way you would solve this, right, you would put this 40 over 1 and you'd cross multiply and use your algebra. I just want to, once again, we focused on algebra, algebraic skills a little bit yesterday. I want to don't forget about the rule, or not really the rule, the step you could use in GeoGebra to solve this. You can enter it exactly as you see it. So 40 is equal to 140 minus x divided by 2. Let's enter that into GeoGebra. 40 equals 2. I would put the 140 minus x in parentheses because we want to divide that whole piece by 2. Right, is that exactly as we entered it? 40 equals 140 minus x divided by 2. Yep, that's exactly as we wrote it. Enter. And then think about your next step to solve for x. You graphed it. Now find the x-intercept. Scroll. Alright, you get your x-intercept. That is your solution, which is 60. Your root, your solution. Alright, so using GeoGebra this time, we found that x is equal to 60. Does that make sense? If we substituted, is 140 minus 60 divided by 2 equal to that exterior angle of 40? It sure is. Alright. Example 4. In the diagram below, tangent DA and secant DBC are drawn to circle O from external point D, such that, very important info here, arc AC is equal to arc BC. So AC right here is equal to BC. Now, just like you mark sides or segments, whatever it is, you can mark arcs with the these tick marks to show that they're equal to each other. They're congruent. Now they tell you below here, if the measure of arc BC is 152, 152 degrees, determine and state the measure of angle D. That's the exterior angle here. So see, as that angle opens up, it hits the minor arc and it hits the major arc. Now we don't have anything right now. We don't have the exterior angle, we don't have the minor arc, we don't have the major arc, so we have to kind of piece together what we have, what they told us about. What could you find first? Think about that. Well, you know that they said in the problem the arcs are equal, so this has to be 152. 152 and 152, they're congruent to each other. That's the major arc. Now the minor arc here, how would you find that minor arc? Well, guys, we know if we go around, in total, we have 152, 152, and a little bit extra to complete the circle once again in its entirety. Alright, so we have 360 in total. So you really have to take the 360. You could add 152 and 152. When you do that, you get 304. So what's left over to make, if we have 304, what's left over to make that 360 in its entirety? So 360 minus the 304, and you get 56 degrees. So the major arc, 152, minus the minor arc of 56, divide that by 2. That gives you the exterior angle of x. So you get 96 over 2 will give you x. And angle D is equal to 48. So you got to strategically piece together what you have. They tell you something, it's important. They tell you arcs are equal, you're going to be using it. If you're looking for the exterior angle, you need the minor arc and you need the major arc. Alright, so there's two intercepted arcs. One of them is bigger than the other. So what I want you to do is try examples 1, 2, and 3. Check back later in the day for your solution. See how you did. Check your work. I just want to talk real quick about some random rules that have to do with a tangent, because we took a look at that today. It says find the measure of angle KLM here. These are just random rules that I've mentioned throughout Module 5 that I just want to show you. What type of angle is this? It's made from really a chord, right, or a secant and a tangent. And look at the vertex. The vertex at L, it's on the circle. So it's the same rule. This is from the very first day of Module 5. It's the same rule as an inscribed angle. It's equal to half of the intercepted arc, which is that 130. Right, this opens up this angle. Look how it opens up. The intercepted arc would be KL, that 130. So right now X is just equal to half of that, which is 65 degrees. And one other rule, the angle formed by the radius of a circle and a tangent to that circle has a measure of what? And this is a diagram straight from your notes. Alright, to show you what that looks like, a radius and a tangent, it forms a 90-degree angle. Alright, like I told you, there's really a rule for the day that we practice, like the exterior angle rule. There's also so many other rules that we need to talk about that aren't full day lessons. They're just things we have to kind of memorize. Make flashcards, whatever you need to do. Try to memorize those rules. Alright, so what I want you to do is complete 1 through 3. Ask me questions in Remind, please. Anything at all, do not hesitate. Your Delta Math is due tomorrow at 8 o'clock. Get a head start on that. And that's really it. I look forward to hearing you. Look forward to hearing from you throughout the day. Have a wonderful rest of your day, and I'll see you mañana.